Morning, guys. How's everybody? Who's online? Just Jay and Caroline. Okay, maybe we'll see Taylor just now. I think Banella is writing the replacement test this morning, so we won't see him online today. Just double check. Finance. Yes. Replacement test for Finance 3 is today. Okie doke. So let me just go back to where I was there. All right. Okay, guys, so I don't want to keep you too long this morning. Thanks for logging in. So just to remind you where we are this week, we're basically right at the end of semester 1 now. So we've got a class today and tomorrow, the 8th and the 9th of June. Yeah, unfortunately, both of them are online, but that's fine. So today we're going to have a look at the very last learning unit 7, the advanced capital budgeting. And that is 3/4, if not more, theoretical learning unit. So I'm quite happy that you guys can cover this learning unit on your own. There's very little calculations that come out of this particular learning unit. It's all just theory, and you've got your learning objectives to guide you through that. So I'm not too worried about that. So we'll just have a look, probably just for the first session. I'll just show you through what's got to be done in learning unit 7 and link it to learning unit 6, because remember what I said, learning unit 6 and learning unit 7, those two learning units belong together. It's basically just the same learning unit. And it's just been split in two. So you've got learning unit 6, capital budgeting applications, and then 7, advanced capital budgeting. So just an extension of the same thing. And remember that these two are your exam chapters. So these 6 and 7, you must learn extensively, learn them together as one unit and learn them extensively. That's your main exam chapters. So that's what we're going to be doing today. And then tomorrow we will have a look at an exam paper online. And then the same thing on the 17th of June, which is next week, our last class on Thursday next week. And we'll also go over an exam paper in class on that day. And then just discuss the finer points of what you, hints and tips for the exams. Okay, so and then that's it. Then we'll be done with semester 1. I haven't written down the exam dates, or have I? Yeah, so your exam date for Finance 3 is the 14th of July. So that, if I'm not mistaken, will be about 3 weeks from the 3 weeks from the date that we have our last class. So you've got plenty of time to revise before the exam. Okay, so then let's just have a look at our learning objectives and themes for learning unit 7. So in learning unit 6, we looked at the actual nitty-gritty of calculating the cash flows and then evaluating the cash flows using 3 different methods in learning unit 6. Now, in learning unit 7, we're just going to have a look at some extra theoretical concepts that we need to bear in mind when we're doing these assessments of our capital projects. So as one of our themes for the whole entire semester has been is risk. Remember, risk and return. So there is a theme for risk and project cash flows. We must always consider risk in whatever it is that we're assessing. So whether it's bond valuations or share valuations or value in a company as a whole, or whether it's evaluating capital budgeting projects, we need to balance out risk and return. And then we just have a look at capital budgeting and multinationals. So when you are an international company, or you are dealing, you might be a South African company and you are investing in a company in Mauritius, or Mozambique or Nigeria or whatever it happens to be, what are your other considerations that you've got to take into account in that multinational scenario? And then, you know, in all of our valuations that we've done, whether it's a share, a bond, any series of cash flows that we had a look at in time value of money, and in our capital cash flows, we use a discount rate in order to calculate the present value of whatever the cash flows happen to be. So we've had a look and we've said that in capital budgeting, when we use the discount rate that we use to do the present valuing must be the WACC, and that will be given to you in a question, the weighted average cost of capital. So in other words, if I'm going to evaluate what my returns from a capital project are going to be, I need to take into account in that evaluation what that capital will cost me. So what will I pay for that finance? Weighted average cost of capital. So now we are going to look at that WACC and we are going to adjust it for risk. So again, here we build in risk into our financial model that we are constructing to evaluate the cash flows of our capital project. So this is theoretical as well. So the capital budgeting in multinationals is a theory section. Risk adjusted discount rate is also theory, but you have to be able to apply it to a question. And then this part over here, projects with unequal lives. This is probably the only little part out of Learning Unit 7 where you have to actually do an exercise, like an example, and where you've got to lay out workings and calculate something. But it's quite simple and it's in the textbooks and you've got examples to follow. So that's not going to be difficult. And I did speak in class last time we met about that principle. In other words, if I'm comparing two projects and I'm trying to decide between them, one project is going to has got a life of 4 years and the other project has got a life of 12 years. And I've worked out my estimated cash flows for both of them. And I've calculated the net present values. How do I actually intelligently compare them? Because their useful lives are so vastly different. So this is a tool that we've got where we can then actually build it into our present value calculation of the two projects so that we are comparing apples with apples. And then this last one is also a theoretical section, real options in capital budgeting. That's one subject, real options. And then a second one, capital rationing, which is also then a theoretical subject that we have to know about regarding capital projects. And also, obviously, we have to apply to our capital project cash flows. So this is how it's broken down into the objectives. You must be able to recognize the impact and importance of risk while analyzing capital budgeting projects. Then you must be able to apply break-even cash inflow, sensitivity analysis, and scenario analysis, as well as simulation as behavioral approaches for dealing with risk. So now we've got to take risk into account. So this learning objective 2 has given us various tools that we can use that will give us an idea of how much risk is in our project. So can you remember earlier on in the learning unit when we did our learning unit on risk and return, what are the calculations that we do that will allow us to assess the amount of risk in some kind of investment? What are the calculations that we've already done regarding risk? Can you remember? Formulas, they're on your formula sheet. And they would have formed part of your, I think it is at your test 2, or was that still in test 1? Who can remember? You would have had to just learn it now for test 2. What are the calculations that they've already given us that allow us to assess the amount, quantity of risk in an investment? Remember learning unit 3, procedures for assessing the risk of a single asset, procedures for measuring the risk and return of a portfolio. And we did correlation and diversification when we looked at a whole portfolio of investments. So what were those calculations that we did? Anyone remember? Nope, no. Remember, we had calculations where we calculated the standard deviation of our set of cash, of our portfolio. I can't spell this morning. And then the coefficient of variation. The standard deviation was a measurement of the quantity of risk in our portfolio, and then the coefficient of variation then broke that down to a quantity of risk per percentage of return that we were going to get from that project. And then the other two things that you must go back to Learning Unit 3 and revise when you're doing this Learning Unit 7 is you'll see in Learning Unit 3 you were introduced to sensitivity and probability analysis. And we take another look at that in Learning Unit 7 as it applies to capital projects. So please go back to your number 3 risk and return learning unit, because remember, when you get assessed at any point, we always assume that you know what you've already been assessed on, because we've already taught that, you've studied it, you've learned it, and now we're just adding to that. Okay, so the sensitivity and scenario analysis is kind of a little bit of what we've already discussed in Learning Unit 3. We're now applying that to capital projects. Number 3, unique risks faced by large and multinational companies. Then number 4 is risk-adjusted discount rates. And then number 5, you have to be able to select the best group of mutually exclusive projects with different lifespans using annualized net present values. So there's 2 calculations in this learning objective 5. You must be able to do the calculation for the projects with different lifespans and then calculate an annualized net present value for that. And then number 6, real options and capital rationing. Okay, so there's quite a lot in this learning unit. So don't be fooled by it's like the last one right at the end of the chapter and it's mostly theoretical, but there's a lot in it. So let's go and have a look at, I can't remember if I've already uploaded these for you or not. If I haven't, then I will. These module outlines, which is basically just a list of the learning objectives, and then the lesson plans, which give you a breakdown of the learning objectives and where you'll find the work related to each learning objective in your textbook. Okay, and just remember these page numbers on this lesson plan are from a 2020 textbook, so they might not be exactly the same as this year's. And these dates over here on the right-hand side, just ignore that because that was used for last year. And I just haven't had time to take these PDFs, and because these are PDFs, so I need to go back to the Word file, take these dates out and resave it as a PDF, and I just don't have time for that right at the moment. So just ignore that. Okay, so these lesson plans, as I'm sure you remember from last year, the way that they were constructed was that down the left-hand side here, you've got the learning objective. And then in the column next to that, it tells you where in the textbook you will find the material related to that learning objective, and which examples and questions are the ones that you need to go through to learn how to apply that learning objective. Okay. And then in this last column, other non-VC Learn resources. Some of these resources you'll find are Learn videos, and some of them come from outside, but these are really good videos. And even if this is a 28-minute video, if you're going to sit down and you're going to learn 6 and 7, I would come here and click on this and watch this video first, just to give yourself a nice broad overview of this whole subject of capital budgeting and the procedure and everything. explains it in simple terms, and then you can go to your textbook and learn your calculations. It's going to really help to make it easier for you to remember and learn. And then this one over here is an article explaining scenario analysis. And then on the second page, we've got our other learning objectives, and that follows on from above. And then here's our other learning objectives, page numbers in the textbook for each one, and exercises that you can do for each of these learning objectives to practice. And then again, anything that's useful as an outside source for you to read or watch. So this is risk-adjusted discount rates, a little explanation of that in an article. And then just take note right at the end over here. This is the last learning objective. I've made a note to say, take careful note of the 4 revision questions at the end of the chapter starting from page 217. So it might not be page 217 anymore. Because I say that's the 2020 textbook, but remember those end of chapter revision questions in your finance textbooks are very important. Those are more comprehensive questions. They're not as simple as the ones inside the chapter, and those are usually the level of question that you will be asked in an assessment. Okay. So if you go and have a look at your textbooks, sorry, just need to drink. My throat is so sore this morning. Not sore, just dry. I think it's this. The cold, when the cold weather starts, everybody's bodies just start drying out. Okay, so in Learning Unit 7, the introduction, there is a lot of, this is page 191, there's a lot of important information in the introduction. So please, in any of your chapters, particularly in financial management, okay, we're only doing finance this semester. Introductions are important, and I have seen many times where they have taken test questions from the information in the introduction. So then over the page on 7.2, we've got risks and project cash flows. Did we do this example 7.1 in class already? Why does it look like, looks familiar? I don't think we started Learning Unit 7. But you've got 7.2.1, break-even cash flow is the first calculation that you've got to do. So you guys know what the break-even principle is now, because you were introduced to that in finance in second year. And we already said that the one method that we've got, the payback period method, is kind of like a break-even calculation as well, except in that it's a break-even calculation that doesn't include time value of money. So this is now a break-even cash flow where we are working out an actual break-even cash flow, taking the time value of money into account as well. But just take note, this break-even cash flow, if you look at the answer, we are solving at the end for CF. If you have a look at the, just go back here to the chat. The break-even cash flow that we are solving for, the variable, is CF at time 0. Sorry, not time 0, it's CF N. So what we're going to calculate here is a single cash flow amount that basically is equal to a PMT cash flow. So what we're calculating here is what would the PMT be? And remember, your PMT is your regular annual cash flows that are linked with any kind of an investment. If it was an annuity, okay, remember PMTs are only linked to annuities. So what we're doing here is we're saying if this capital project, if we turn the cash flows into an annuity, in other words, equal regular amounts of cash flow, what would the PMT be in order for us to reach break even? Okay, so it says here we are assuming equal annual operating cash flows. Remember, this is theoretical, so we know it's not really going to happen in real life with our project, but we use these theoretical formulas to assist us in being able to assess our projects. So if you have a look at example 7.1, the company is considering investing in 2 projects. They appraise all their projects using a WACC of 12%. And now assuming equal annual operating cash flows and a 0 terminal value, the break-even cash flow of both projects is calculated as follows. And then we are using the formula that they've given us above, which is we are solving for the variable CFN equals, and then the formula that has been changed around. I just want to have a look. I have got the formula sheet loaded here. I just want to check to see if this formula is on the formula sheet or not. Let's just take a quick look. I just want to see if the formula that you need to use is on here. And if you have a look, remember this break-even cash flow, it says that we take the net present value formula, which we had in learning unit 6, and then we change it around so that we are solving for CFN. I don't see it here. That's the variable growth model. I just want to have a look here so I can tell you. Our net present value formula. And remember our internal rate of return, the IRR, we also take the net present value formula and rearrange it in that case to solve for solve for ZF0. In other words, we force the answer to be 0. Net present value on page 172. Page 172 in your textbooks is where you've got the net present value formula. And it's that formula that we then rearrange on page 176. Okay, let me just write this. Page 172 is the net present value formula. Then on page 176, we rearrange the NPV formula so that we can calculate the internal rate of return. And then on page 192, we rearrange the NPV formula so that we can calculate the value for CFN. So that means you need to memorize that formula on page 172 you need to memorize how to rearrange it to calculate an IRR and how to rearrange it to calculate a break-even cash flow on page 192. So if you learn those three together, the NPV formula, the formula for IRR, and the formula for break-even cash flow of a project, then you will be okay because it's those three formulas together. It's all the same formula that you're just using for a different purpose. Okay. It's not on your formula sheet. Go back here. Okay. So that's break-even cash flow, the help that I can give you there. Then if you go on to 7.2.2 on page 194, which is the sensitivity analysis, that's the second part over here. Apply break-even cash inflows, part there, 7.1. Sensitivity analysis, that's this one here. Scenario analysis, and then computer simulation. So this is broken down into the 4 different sections. So the example 7.1 we've already looked at. That is the break-even cash flow. Okay, and then I've put the note over here on lesson plan. Note that what we are calculating here, in other words, CFN, is the equal annual cash flow, which is similar to PMT in an annuity. It's just a theoretical formula. So now we come to this one here, sensitivity analysis, which we've already covered in learning unit 3. So go back there, revise what we're talking about when we talk about sensitivity analysis, and then you come here and read this sensitivity analysis and have a look at your example 7.2. So just remember, with sensitivity analysis, we have got a project that's got various inputs, different variables that will affect the outcome of our project. And with sensitivity analysis, we test one by one the effect of changing that one individual variable on our final outcome of our project, so that we can tell of all of our variables that input into our project, which ones will affect the outcome of our project more than the others if they were to deviate from our estimate that we've used in our model. And then we've got limitations of using sensitivity analysis as well. Then 7.2.3 scenario analysis. Let me just follow the questions we've got here. Question 7.1 goes with example 7.1. Example 7.2 is sensitivity analysis. And then example 7.3 is the scenario analysis. So when we talk about scenario analysis, as opposed to sensitivity analysis, in scenario analysis, we have got our estimate of the cash flows that we have done to the best of our ability, as most accurate as we possibly can. But because we know that they're estimates, we know that it's highly unlikely that they're going to come out exactly as per our estimate. And so we say we do what we call what-if analyses. And this is done a lot in business. And it's referred to usually as what-if analysis. So then we ask ourselves the question, okay, so here's our model to the best of our ability. What if things turned out badly and the results and all of our input things were more expensive than we thought they were, our returns and our income is less than we thought it was. So in other words, what happens if the worst case scenario happens? And we construct a model with estimates as if the worst case scenario would happen, and then we do the same for the best case. What if everything went better than according to plan, and our product flies off the shelves and our income is way higher than we estimate, and the economy is really good and all of our expenses are super low? Then what would happen? Okay, so in the middle, you've got your original estimate, and then you've got a worst case scenario and a best case scenario. So that's what scenario analysis is talking about. So if you look in example 7.3, you'll see we construct cash flows for worst case, base case. So base case means our actual estimates, and then a best case scenario. And then that again just gives us an idea. Remember what we're looking for. Do you remember this word from Learning Unit 3? When we want to measure the amount of risk in a project, we need to know what the range is. Can you remember what the range is? If we say, what is the range? Yep. Yes, Jay, what can you remember?
The range would be the best case minus the worst case.
Yes, so basically it's telling us the quantity of the maximum deviation that can happen in our project. And then obviously the smaller that total deviation, the less risky. If you've got a project where you could possibly make minus 1.2 million, or best case you could make 10.7 million, that range between the worst case and the best case is so enormous that how on earth are you going to have any kind of confidence in where you are actually going to land? Whereas if your range is worst case 5 million profit, best case 8 million profit, then you can see though the best and the worst case, the distance between them is so small that your risk is clearly small as well. So that's what this is all about here then in the scenario analysis, and that's what we're trying to assess. What is the range in our for this particular project? Then this last little section here on page 198, computer simulation, is just a small discussion, because obviously all of these things that we're doing here and looking at these examples, we're looking at manual examples, but in big companies, there are computer simulation programs that are specially written that you can input values into all of these variables, and then the computer crunches all the numbers and gives you these simulations for what could possibly happen. And just the point that they make at the bottom there is that computer simulation is more realistic than sensitivity analysis, because it provides an indication of the relationship between the variables, cash flows, and the returns. So kind of, I don't know if you remember from second year when we were doing the allocation of overheads to our product costs. We had 3 different methods that we used. We had the, what was it called? The direct method. And then, what was the second one called? The step method, direct method, the step method. And then we had the linear algebraic method. So using the linear algebraic method, we were allowed to, we could put in inputs for everything that didn't depend on the calculation of the others. And we simultaneously solved our model with all the different possible inputs. So that's what computer simulation can do. It'll be able to give us simultaneous calculation of all the different variables. Whereas for us as manual, we do sensitivity analysis. We can only manually calculate by changing one variable at a time and seeing what effect will that have, and then change another variable and see what effect that will have. Okay. I don't know if you guys have got Netflix, but there's quite an interesting program. I think they've only just uploaded it. It's about, it's a documentary on black holes. And I don't know if you've read about this in the past. They did in about the last 2 or 3 years ago that this whole investigation was done. And for the first time, the scientists were able to actually take a photograph of a black hole using imaging that they did from all over the world. And then they've done all kinds of mathematical equations to work out what actually happens inside a black hole. And part of what they're doing in that documentary is computer simulation, and they show you how computer simulation works. So obviously in the scientific community, computer simulation is used extensively, because then you can model what would something look like if these were the inputs. Okay. So this question point 2 is then a practice question. Calculates the ranges for our net present values and the cash flows for 2 projects. And why question 7.2 is important is because you get to practice your decision-making ability. Okay, in other words, they say which project should be selected and why. And remember, those are the kinds of questions that you must be able to answer in third-year assessments. Not just to do the calculations, but you must be able to explain your result. Then this next section is then the capital budgeting and multinationals. So that really is it's pure theory. So just it is a learning objective, so you can get theory questions on this. So read the pages in your textbook and make sure that you fully understand. There's 4 different aspects of multinationals that they look at: exchange rate risk, political risk, tax risk, and transfer pricing. So you must be able to name the 4 common risk exposures involved in capital budgeting for multinationals, and then just give a 1-sentence explanation of what that particular risk entails for a company. Then our next one is risk-adjusted discount rate. So remember we said we use WACCs. We have to have a discount rate in order to calculate our present values. And usually we are given a WACC for our company, and then that's what we use to do that calculation. In other words, it's our value for R. So R in our formulas equals the WACC. A risk-adjusted discount rate is where we now have to adjust the discount rate or WACC that we would normally use for in our company. In other words, do a calculation, what is the WACC of our company? But now for this specific project, we are going to adjust that rate for the risk inherent in this particular project that we are assessing. So if we were going to assess 3 different projects, we might very well end up using 3 different discount rates. We would start out with our normal WACC and then make an adjustment either upwards or downwards to that rate, depending on how much risk we perceive there to be in this specific project that we were assessing. So tell me, if let's say we've got 2 projects, we've calculated our WACC, and we're now going to calculate the net present value of these 2 projects. One of the projects is considerably risky, and one of the other projects is less risky than the majority of the projects that our company undertakes. For the project that is more risky than the average project the company undertakes, would we adjust the WACC up or would we adjust it down? So let's say the WACC is 8%. Would we make that WACC 9 or 10% for a risky project, or would we make it 7% or 6.5%? If the project is riskier than the average project that our company takes on, in what direction would we adjust that discount rate?
Ma'am, I think up. Wait, no,
Yeah,
down.
yeah.
Wait, is it up?
Well, you must be able to tell me what have you decided and why did you decide that? So it is up. So why did you decide up?
Up. We said that this was more risk. We said that this was more risky, right?
Yeah.
Bringing
So
it
what would
up.
the yes.
Bringing it up means I'm not sure how to answer this, man, because I know that it in bringing it up I think we're decreasing the risk, aren't
Yes,
we?
yes. You're not decreasing the risk. What will happen? The higher the value for R that we use in our net present value, the lower the net present value is going to be. So in other words, the higher the discount rate, the bigger the chunk of our cash flows that we are taking out to pay for that interest. Because that's really what we're doing using a discount by applying a discount rate to a set of cash flows. We're saying here are our cash flows, but I have to take out of those cash flows my cost of capital. So I have to reduce the cash flows by the amount that my capital is going to cost me. And remember, the more risk, higher return, higher the risk. Lower return, the lower the risk.
Yes, ma'am.
So if there's going to be high risk, we need to use a higher percentage to then calculate the net present value. So remember our, and in other words, we have to allow for the fact that the cost of that project will be high. So remember our CAPM formula that we had, what learning unit was that? I think that was also in risk and return, at the end of the risk and return formula, chapter, page 93. Let me just have a look. Yeah, your CAPM formula, also in learning unit 3, risk and return. Remember, we said that CAPM equals the required rate of return, taking the beta of a particular investment into account, and that value for beta was directly linked to the amount of risk in that investment compared to the market as a whole, as an average. And we said that market risk equals a beta of 1. So if our project has got a higher risk than the average market, the beta then might be 1.5 or 2.3. And if the risk in our project is lower than the average in that of the market, then the beta of our project would be 0.7 or 0.5, whatever it happens to be. And then using that, putting that value for beta into the CAPM formula, it then calculated what our required rate of return was. So again, the higher the risk, the higher the beta, and that would then equal a higher risk-adjusted discount rate, i.e. CAPM, i.e. required rate of return. Okay, so all of those are linked. CAPM formula calculates my required rate of return, and my required rate of return must be a risk-adjusted rate of return. So I use beta to indicate the quantity of risk. Pardon the typing there, I'm just trying to do it quick. Okay, so risk-adjusted discount rates, we now go back to learning unit 3, bring our CAPM formula in, and we now use that to calculate a risk-adjusted discount rate. So then you've got up until example 7.5 and 7.4 and 7.5, all that, the discussion of risk-adjusted discount rates, but then go to page 204, applying RADR in practice, and question 7.3, because obviously that's what you're going to have to do, is be able to apply it in a simulated scenario. So your question 7.3 will be very important for your risk-adjusted discount rate section. Okay. And it's not a difficult question or example, so you'll be able to understand, as long as you understand what a risk-adjusted discount rate is and why we are adjusting it, you'll understand it and you'll be able to then follow that question and the examples. Okay. Any questions up until now with all these bits and pieces that we've gone over? It's kind of like a lot of little, it's in Learning Unit 7, they're kind of tidying everything up for us and giving us all these extra little things that we have to take into account and remember when we are assessing capital projects for a company. Okay, so then I think this will probably be the last one that we have to look at, is then comparing, is it on the screen? Yeah, here in the middle. Select the best group of mutually exclusive projects with differing lifespans using annualized net present values. Okay, so this is another one where it's a practical question that you would have to, they'd give you a scenario and you have to do a calculation. So we need to be able to compare projects of unequal lives, and then we need to be able to calculate an annualized net present value from our calculation that we have done in 7.5. We then convert it into an annualized NPV. So we use the same data as we use in example 7.6, which was, sorry, yeah, example 7.6 and 7.7. I just haven't listed all of them. From example 7.6, example 7.7, and 7.8, all three of those cover this section over here, unequal lives and annualized net present value. So if you have a look at, do you want to have a look at that? Yeah, I'll have a look at example 7.6, because that basically gives us the data that we're going to work with in these three examples. So we've got two mutually exclusive projects. So remember, mutually exclusive projects means that I can only do one of them. Project 1 has got a lifespan of 2 years and project 2 has got a lifespan of 4 years. The company's cost of capital is 15%. So remember, cost of capital is the same as a WACC. And the cash flows and net present values of both projects are summarized as follows. So we've calculated their cash flows and we calculated what the net present value was. So for project 1, the first line of the example is initially cash flow 15 million out, and then in year 1 and year 2 a cash flow in of 15 million. So using a WACC of 15%, we calculate a net present value of 9 million. Then for project 2, which in initial outflow of 30 million, followed by 4 years of cash inflow of 15 million, we net present value those cash flows using a WACC of 15%, and we get a net present value of 13 million. So if you were just looking at that, if that was all that we calculated, and we looked at that, which project would you be inclined to choose? Project 1 or project 2? You would probably choose project 2. Yep, merely because when you look at the information like that, it appears that project 2 has got a higher net present value, so therefore surely I would choose project 2. But now we have to have a look. We have not taken into account the fact that those two projects have got differing useful lives. So in order to be able to make them comparable so that we are comparing apples with apples, we have to adjust the data to make the two useful lives the same. So what we do is we have to look for the lowest common denominator out of the useful lives. So the one is 2 years and the other one is 4 years. So what's our lowest common denominator for 2 and 4? Remember, lowest common denominator means the lowest value that is divisible by both of our numbers. Don't know if you can remember that from maths. No, it will be 4, because you can't divide 4 into 2. We want an answer of a whole number. So if I take 4 and I divide it by 2, 4 is divisible by 2, and 4 is also divisible by 4. 4 divided by 4 is 1, and 4 divided by 2 is 2. So if you got a project that was one project that was 3 years and another project that was 4 years, what would be your lowest common denominator? The lowest number that both of those could be divided into and give you a whole number as an answer. Can you work it out? It would be?
Sorry, ma'am, my keyboard is not working properly.
Oh, okay.
You're saying that the lowest that can divide into both 3 and 4.
The lowest that 3 and 4 can both be divided into. So what number could I divide by 3 and also divide by 4? And in both cases, it would give me a whole number as an answer.
I'm thinking 12.
Yes, you're right. You're right. 12.
Oh, okay.
So 12 divided by 3 will give me an answer of 4, and 12 divided by 4 will give me an answer of 3. But there's no number lower than 12 that I could divide, because if I say 3, the next one up is 6. I can't divide 4 into 6. The next one up is 9. I can't divide 4 into 9. The next one up is 12. I can divide 4 into 12. And then if we're using 4, and if I multiply that by 2 is 8, but I can't divide 3 into 8. And then 3 times 4 is 12, but I can divide 3 into 12. So the lowest common denominator for both of them then is 12. Okay, so you have to be able to establish that, because they like this question in a test, and they can give you 2 projects, one that's got 3 years and one that's going to last for 4 years, and then you have to work out that the lowest common denominator is 12, so that you can then equalize the cash flows. Okay, so then let's just go and have a look at example 7.7 so that we can see how we lay our workings out in order to equalize the cash flows. So at the top row of example 7.7, we have got our project 1 with the cash flows as they are now. So now we've got to extend those cash flows to 4 years. So currently I've got 15 out in year 0, and then 15 in year 1, 15 in year 2. So we do what is called the reinvestment assumption. And we assume that at the end of the project, in other words, at the end of the 2 years, I will take my initial investment that I invested into project 1, and I will reinvest it into a similar project. So if you look at that first row, the top half of that first row has got our project one's cash flows as we have it. Below that, we've added a second row in year 2. At the end of year 2, we've got cash flow in of 15, but then at the end of year 2, we've taken our 15 million investment and we have reinvested it. So in other words, in year 2, we've now got another outflow of 15 million. And then we repeat the cash flow in year 3 and year 4, the 2 years of inflow. So now, if I look at that, I have now got cash flow for 4 years. 15 out in year 0, 15 in year 1, 0 cash flow in year 2, because I've got 15 in and 15 out. And then in year 3 and year 4, I've got 15 in and 15 in. Now taking those values, we present value them using our present value factors as per normal, and I now calculate a net present value for project 1 of 17 million. Now I can compare that 17 million for project 1 over 4 years to my 13 million net present value, which was project 2 over 4 years, and that I can see that actually project 1 is the better investment, because when I convert them both to a 4-year investment, my net present value from project 1 is going to be higher than from project 2. So that's just an illustration of how we can compare projects of unequal lives. We can change our models to make the lives equal and then compare the net present values. But remember again that net present value is an absolute value. It's a rand figure, which is difficult for us to make sense of. So we're now going to convert that net present value rand figure into an annualized net present value. So over here on page 208, 7.5.3, and if you were to use question 7.4, that includes the reinvestment approach and ANPV. So question 7.4 is your go-to question for practicing this whole section. So if you go to example 7.8, you'll see our steps for calculating annualized net present value that they've got in the textbook in the bullet points just before example 7.8 says step 1, calculate the net present value of the project using its given project life. So project 1 for 2 years, project 2 for 4 years. Then step 2, divide the project's net present value. So remember, this is now the net present values according to their actual lives, 2 years and 4 years, not equalized. Now we take the rand value of the rand value of each net present value, and we divide it by the present value annuity factor over the project life, and this will give us the annualized net present value. And then step 3, you compare the ANPVs, and the project with the highest ANPV then is the one that is preferred. So if you look at example 7.8, you see where they are talking about this present value annuity factor. So that comes from the time value of money annuity tables. So you need to go and look that up using the cost of capital for the project and the number of years of useful life of the project. So what was our, going back to 7.6, our cost of capital was 15%. So using 15% and 2 years for project 1, and using 15% and 4 years for project 3, but looking the factor up on the annuity tables, you then get that annuity factor. So we divide the 9 million by project 1's annuity factor, and we divide the 13 million by project 2's annuity factor, and we get ANPV of 6 for project 1 and 5 for project 2. So we can see by also using the ANPV, project 1 is also coming out on top. So using both methods, equalizing the lives of the project and then calculating NPV, and also calculating an annualized net present value amount. Using both of those methods, project 1 has actually beaten out project 2. So those are another 2 methods that we can use in advanced capital budgeting to kind of like really make sure that we are making the right decisions. Yes, Jay?
Now, it's just interesting to point out that how we both thought that project 2 would be the best one just from face value, but then these calculations, are they that accurate to determine whether or not our investment really is worth it?
That's exactly why we do them. And that's exactly why we're doing it, because if you just looked at face value, if you just calculate simple net present value, you would be fooled. You would think that project 2 was the better option. But you've got to realize that because those 2 projects do not have equal lives, you can't just look at the net present values. You have to either calculate an annualized net present value, which also takes the life of the project into account, or you have to calculate the reinvestment assumption and calculate the NPV, making their lives equal. And only then are they really comparable.
Is it possible that in our exam we have to answer for both of them using both
Quite
methods?
possible.
I mean,
quite possible. Yeah, they could give you an example just like this data, like in example 7.6, and then they could say using the reinvestment assumption and the annualized net present value, supported by calculations that decide which project the company should invest in.
Sounds like a 20-mark question, yeah?
It all depends on how many cash flows there are in the project. Like this example, there's not very many cash flows, but so it wouldn't, your calculations wouldn't be very long. I mean, look at example 7.7. That's not a lot of calculation that you've got to do to get your net present value of 17 for project 1. And then in example 7.6, you've calculated your net present value for project 2. And then in example 7.8, calculating the ANPV, it's not a long calculation. You've got to have your NPV, and then you've got to divide it by the annuity factor.
Well, I'll just see how it goes, ma'am.
So yeah, don't start worrying about it just yet. It is a lot to remember, but remember, you guys have already learned everything up until the end of Learning Unit 5 for your Test 1 and Test 2. So it's really, that will be revision, and you've just got to add your 6 and 7 now. So that really brings us to the end of all the stuff where there's calculations in the textbook. Then this very last section over here that you can see on the lesson plan, the role of real options and the procedures for selecting projects under capital rationing. I'll leave you to read that through yourself, because that's just 2 theoretical sections of 2 different other aspects of capital budgeting that you need to be aware of and that they can ask you theory questions on. So that basically then covers Learning Unit 7. So you can go through Learning Unit 7 and see if there's anything that you don't understand. And then today is the 8th. And then tomorrow, I want to go through an exam paper, or as much of an exam paper as we can in the time that we've got. But then you can also obviously ask me any questions on Learning Unit 7 that you've come across. And then finally on the 17th of June, make sure you've got all your questions ready for the 17th of June. Okay. So that's it for today. Thank you for sticking around I wanted to just get through to the end in one section so that it's one recording, because that's much easier for students to follow. So I'm going to stop the recording.